This one is the on fixed point method. So let's consider the function f of x equal to x cube minus 2x square minus x plus 2. So we have to find first, state the roots of the function, okay, x star, and then we construct three different fixed point function g of x such that f of x equal to 0. That means g of x equal to x. That's what it means. And find the convergence rate for g of x. That means constructed in the previous part. That means in this part B we construct three three different form of g of x, and for each form we need to compute the convergence rate. Remember, convergence rate is the lambda that is we are going to compute, and then if it is converging, then need to figure it out which root it is converging to with respect to the answer in question number A. Okay, if it diverges, there is no solution, that is out of the question. Okay, so I hope the question is clear. So first, for our better understanding, let's check how the graph looks like. Okay, it is a cubic function, so definitely it has three crossing point. Okay, so let's see if we draw the graph, it will look like, let me draw the axis first. That is your x, that is your f of x. Okay, I can see here the, so let me write the roots first. Okay, the roots of the 0 are the following. You can do very easy algebra. So if you write x square, factor it out, is x minus 2, and then here is minus 1 is factored out, is x minus 2 equal to 0. So that is equal to x square minus 1 times x minus 2 equal to 0. So the solutions are x, which is the star is the root, equal to plus minus 1 and 2. It has 3 root, as it should be, because it is a cubic function. Now, so graphically, the graph of f of x cross the x-axis at plus 1 and at minus 1 and at 2. Suppose there is a plus 1, there is a plus 2, there is a minus 1. Minus 1, plus 2. And look at the y-intercept. If you put x equal to 0 here, y equal to 2. That means it is a 1 here, 2 here. That is your x-intercept. That means function, I'm just sketching the function. It is like that. So that is a cubic function. So there is a one root here, and one root here. There is an x3 x star. Okay, that is the first part of the question A. Now we construct g of x for this function of x. Okay, and when you in part C, when you compute the convergence rate, then we need to find out of these three root which root is converging to, if it converges. Okay, let's see. The first thing that we are do compute, the part B is now we are doing. So g of x. The first thing is that you can check here that we have x square, sorry, x cubed minus 2x square minus x plus 2 equal to 0. That is the root. F of x equal to 0. So this is x, so we can write here x cubed minus 2x square plus 2 equal to x. That means this is our g of x. That means this satisfies g of x equal to x. So our g of x, this g of x here is our g of x. Okay, that is the one choice. So that is our, let's say, first choice. Second choice, we can say we take, let's see how do I write it. Okay, so 2 is a constant, we take it out on the other side and factor out x and divide. So it is a pretty easy way. So we can write x factored out will be x square minus 2x minus 1 equal to minus 2. So we can write here that x equal to minus 2 divided by x square minus 2x minus 1. That is our g of x. So let's use the second choice. Okay. So this whole thing is our g of x, right hand side. Third choice, okay, what we do, let's see, let's take this square here and take that everything in other side and take this square root. Okay, so we can write it will be x cubed minus x plus 2 equal to 2x square. So from here we can compute that x divided by 2 and then square root. So the x will be equal to, let's take the positive square root for simplicity. Okay, it will be plus, uh, it will be 1 over root over 2 times root over x cubed minus x plus 2. That is the third one. So these are the our three choices for the g of x. So this is our second part of the question. We constructed three different g of x. Third part says that we need to check the convergence rate. So there is the third part. See, here the convergence rate is the following. Convergence rate, the lambda is equal to g prime at x star. What does it mean? It's dg divided by derivative dg by dx at x equal to x star. That is the formula. So now let's take the first choice. Here g of x equal to x cubed minus 2x square plus 2. So from here we compute the g prime of x, which is pretty easy, 3x square minus 4x, that is. Now let's compute lambda. We need to put x equal to plus 1, minus 1 and 2, then we get a lambda at plus 1, minus 1 and 2. So lambda equal to g prime at x star. Now we have three results. Okay, so now if we put x star equal to minus 1, it will be answer is 7 for x star equal to minus 1. So it is diverging, no solution. And if you put x star equal to plus 1, then oh sorry, my mistake, that is absolute value by definition. It has to be an absolute value, lambda. Okay. So if you take the absolute value, then it is actually absolute value of let me see, if you put a minus 1 plus 1. Now I am going to put plus 1 here. If you put a plus 1, the result is a minus 1. Sorry, here is a minus 1, okay, which is equal to 1. So that is also not less than 1. So it is x star equal to, for x equal to plus 1. So it is also diverging. No solution, because it is not less than 1. It has to be, for converging, it has to be less than 1. And finally, we have a you put x star equal to 2 here. 4 times 3 is 12, minus 8 is 4, that is equal to 4. So that is also greater than 1. This is for x star equal to 2. That means also diverging. Okay, because for converging, remember that we need lambda less than 1 for convergence. So it is not made. So for all these three value, the greater than, let me write it here, is greater than 1, that is greater than or equal to 1. That is because single greater than equal to, not only greater than equal to 1, greater than equal to 1. Greater than actually, not equal to, so you don't have to write it. So divergence is for lambda greater than equal to 1, and convergence means lambda has to be less than 1, or between 0 and 1 actually, but less than. So for the first choice, we do not have any converging point. Okay, Let's try the second choice. For second choice, we have a g of x given by minus 2 divided by x square minus 2x minus 1. So first we compute g prime of x. So it is pretty straight. So you can use UV method. But remember, look at here. If you take the minus 1 here, if you take the derivative, minus minus become plus, and there is 2x, it is minus 2, so it is 4. So it is really straightforward. So 4 times x minus 1 divided by this minus 2, x square minus 2x minus 1 whole square. That is our g prime of x. Now we need to compute these three values for the three root g prime of x at three different roots. Therefore, lambda is equal to magnitude of g prime at x star. So now plug in the values. So whenever minus 1, if you put x equal to minus 1, then we get this equal to 2, which is greater than 1 for x star equal to minus 1. So it is a diverging, so no solution. If you put x star equal to plus 1, then we get equal 0 for x star equal to 1. That means it is super linear. And then finally, when you put x star equal to 2, we get 4, which is greater than 1 for x star equal to 2, which is diverging. So first choice we didn't have any solution. Second choice we have only one solution out of the three possible computations. So it is lambda equal to 0, which means it is superlinear, and this superlinearity occur for the root x is equal to 1. That means it will, the function will converge to x star plus x is equal to plus 1, and it is superlinear. So I'm answering the part C here actually. Okay. So here for second choice, yeah, g of x is converging to x star equal to 1. That is the solution or answer for part C for the second choice. Let me see, I'm doing it right way or wrong way. Let me see. No, correct. And for the other one, the third choice, we do this way. Third choice, we have a function which is given by, g of x is given by, now 1 over root 2 times x cubed minus x plus 2 to the power half. Okay. So now compute the g prime of x, the for lambda. We compute lambda from later. G prime of x, if you take the derivative, it will half come out and minus half, so it will down is 3x square minus 1. It is also pretty straight. It will be 3x square minus 1, and then here is root 2, and there will be half 2 root 2, and so I have a 2 root over 2 times x cubed minus x plus 2 whole to the power half. That is our g prime of x. Now let's compute lambda, which is equal to g prime at x star absolute value. Now we just plug in the value of x here. It's pretty straightforward. With a calculator you can just type in. We put x equal to 1 and then minus 1 and then 2 and write down the result. So it's pretty straightforward. So if you put x equal to 1, the first one is 0.1, less than 1. So it is linear convergence. Okay. And then that means if we start the iteration close enough to 0.1, So let me then it will converge to that point. Okay, that means if we for x star equal to +1, and if you put -1, then is also 0.5, which is less than 1. That means linear convergence and converges to x star equal to -1 whenever we start the iteration close to x equal to -1. And the last term, the finally whenever we put x equal to 2, we get 1.375, which is greater than 1. It is greater than 1 for x equal to 2, so it is divergence. No solution. So that is your convergence. So part A, we found the root and it says the graph, which the roots are +1, -1, and 2. The second uh, part B, we computed three different possible g of x, and third part we computed the convergence rate for all these three g of x at these three different roots. So for the first choice, we did not find any converging point, means that all three are diverging for all three roots. For the second one, it is only all are diverging, but only one is converging, which is superlinear at x equal to 1. And for the last third choice, we have now one diverging and two linearly converging, not superlinear. That means, and those are converging to x equal to +1 and x equal to -1. So that is how we can test the convergence rate for different kind of function. So that's all for today. Thank you very much.